One of the most exciting and controversial issues in the history of behavioral science is the emergence of relational behavior. This is, do animals, non-humans, and humans perceive and respond to relational qualities of stimuli, regardless of the absolute attributes that each one possesses? In spite of the cited controversy, there is strong evidence that supports the emergence of relational behavior in animals and humans. Different paradigms have been used for the analysis of relational behavior. The most extensively employed has been the transposition task. Relational behavior under the transposition paradigm has been usually studied in simple choice situations with only two stimulus options, in which participants are not allowed to display patterns of activity with respect to stimuli. On the other hand, the study of relational behavior in animals is more extensive, systematic, and has stronger evidence than in humans. The main reason of this is the ceiling effect, frequently observed when the participants are humans. In this context, recently challenging tasks have been proposed based on transposition for the study of relational behavior in humans. In this way, the present work advances from the previous ones and presents RBDT, a paradigm based on a modified transposition task for the continuous analysis of relational behavior in humans. RBDT was designed to allow the integration and continuous analysis of patterns of activity in the study of relational behavior.
RBDT was programmed in Java. It automatically